Hey there, welcome to the channel. I'm Brian, and in today's video, we're going to talk about this board 005. Now, board 005 was a board that I had bought as a no-fix board, and it had the old heat sinks on it. And I took it all the way from a non-working board, 0 A6, all the way to 65 A6, put the new heat sink on, I then got myself in a mess of trouble. So I will tell you, it does make it into a miner at the end, but it was a long journey. So stick around and find out what all I went through to get this board working. All I know about this board so far, it came in, it was a no-fix board from another repair shop. I just stripped off the heat sinks that were on it. No, it was not already upgraded. I just set the heat sink that I'm going to use on it. I just set it there. First thing I see is chips missing. So, well, let's clean it up and let's put a chip on. That's easy enough. No sense in really testing anything until I get to that point. I'll do a quick visual inspection, and then we'll replace that chip that's missing, because that definitely needs to be done. Okay, so the only things, I found a few solder balls, but the only other thing was really the fact that we've got one chip here, and we have one chip here that needs to be replaced. Miner or testers all set up. Hey, I changed out the interface a little bit, so there's more of the board showing and less of the tester showing. Let me know in the comments below. Do you like that? Did you want to see the little parts of the application across the top? Let me know if this layout is working well for you to see what's going on when we're testing a board. All right, let's go. Let's see what we get. Drum roll. Ooh, baby. Two chips. Oh, come on. It can't be that easy, right? Let's check it out. Let's do the Temp Sense test. Oh, 71 chips. That's never a good sign. So there's something wrong in the signal path, but I really can't tell you what it is. But we've got all of our chips working well. 4.3 amps of power at 19 volts is pretty normal. Okay, there's some heat on this side, on what I call the cold side of the board. That, according to the team miner, it's this side, but we know different. If you haven't already seen it, check out my backwards video. Will explain what I'm talking about. The temperature sensors on the team miner are being reported backwards from the way they're reported in the miner. Okay, I'm happy with this. I'm going to go ahead. I'm going to do what I always do in this case. I'm going to upgrade this board so that it works with the new and improved heat sinks. And so I'll clean the top of the chips off, and then I'll put all the nuts on. And frankly, I'm going to have to wait a little bit because my new thermal paste, specifically made for these boards, is not here yet. It left the shipper on Friday. It's supposed to be here today. So let's see if I get here by the time I get finished cleaning up the board. Let's do that now. Okay, so got all the nuts positioned in place. Now I'm going to use my hot air station. I'll use at 500 degrees and 100 on the airspeed. I'll have my large tip soldering iron on standby at 440. It's warming up right now. So let's just get to it. So we got 0 chips. So something, when I put all that heat in there, something got unhappy. We'll just try it from starting from 30. Okay, I got nothing. Ooh, I got 12, but I should have 20. Okay, I got 10. So I got 10, I should have 10. That's good. All right, we'll go to here and we'll get 15. No, we won't. We'll get all kinds of numbers. Okay, so there's something funny there. Let's just see if we can get 11. Okay, I can't get anything that's stable. Let me get my sharp tip on here. Okay, let's check here. I got a good 10. That's good. Let's go for 11. No. So, most likely that chip, because it's right there next to a nut. So let's look at that chip under the microscope. I actually expected these legs right here to have come out. So let's just reflow this one. Okay, 10's good. 11's good. Twelve's good. 13's no good. Again, that's one right there by a chip. Honestly, it looks like the same thing. Let's just heat it up. Give it a little bit of fresh flux. There's a lot of flux on this board already, but it's cooled off. Let's see what we got now. Okay, we're making progress. We got 12 chips. We just reflowed that chip. Let me check it back here. 11, that's what I expect. 12, that's what I expect. Well, let's take it off. Okay, it looks like 13 has had time to cool off. Let's see what we got. Oh man. Okay, so maybe 13 wasn't the problem because that's a new chip. Let me check things around here. It could also be that 12 is giving us problems. I've seen that happen before. So let's do this. Let's check our voltage. Just to make sure. Yep, 1.7. Usually if it's good at this end of the board, then it'll be good all the way down, but let's just check it to be on the safe side. .7. 1.7. 7.8 basically. Okay, so that's good. Let me reflow 12. Can you spot the problem? right there. Let me get my favorite tweezers for doing this kind of work. Good. I bet it works now. Woohoo! All right. So that's a great sign. We got, so maybe 13 really wasn't bad. Maybe it was. That resistor missing right there would cause all kinds of weird behavior. Okay, so we need to get to 58, right? So 60 is right there. 59, 58. So let's do an inspection. Did anybody else lose a resistor? Ooh, I can tell you right now. We lost a resistor. We can do two things. I can A, look it up in the spreadsheet, or B, I can jump over two domains and I can see that it's there. See? So let me go check my cheat sheet. All right, that is U94. All right, and I'll look back under there real quick, and that is R968. It's a 33 ohm resistor. Let's get back under the microscope. Yeehaw! So a couple of resistors, and we are back in action. 65 chips. Whew. All right, let's check out our temperature sense. Okay, so we have some weird temp sense problems. Yeah, all kinds of crazy values. So I'm gonna do, I tell you what, this board is so messy right now. I'm gonna go ahead and put it in the alcohol bath, just get it cleaned up so it'll be a little easier to work. Chip 65 has been changed out. Board's all cleaned up. Let's find out where we are. 65 chips. Boom. All right, let's see if the temperature sensor behaves better now, shall we? Okay, there's something funky going on. You see the temps jumping around. So 65 has been replaced. I'll go ahead and replace number 1, because sometimes 65 or 1 will be messed up. So I'll go ahead and replace 1. That's also happens to be a chip by a nut, so maybe that's a problem. Changing out 65 was good because it was, that pad was filthy, it was corroded, it was pretty ugly. And now we've got no temps on any of them. I think I'm just going to reflow this chip. It looks really good, and then I'll start doing measurements. Okay, let's see what we got now. Okay, looks good. All kinds of crazy values. Okay, I'm gonna check temp sensors on the back of the board real quick. See if maybe they fell off. There's one. There's the other. Okay, so when I check the RO voltage on the last domain, the 13th domain, we've got some good stuff. Let's see, what if I check the RO voltage here? What? That is bizarre. Okay, let's check the RO voltage here. Okay, so it's good here, but it's not good there. Not happy with chip 60, so I'm going to replace chip 60. Let's check our voltage. See, that's low. That's part of the problem. Okay, that's right. But the 1.8 is low. I'm just going to start all the way at the bottom of the domain. Hell, that LDO is bad or something. Let's just check the next domain over. Okay, so we got two domains that are wonky. Alright, so it looks like this one is weird. It's low. And that one's low. But the 1.8 or the 0.8 is good. Alright, let me check it on the back side. Push this out of the way. Good. There we go. .5 coming out of the LDO. 1.47 coming out of the LDO. I need to take domain 7 and domain 12 and 11. I need to replace those LDOs. Oh, look at that, 55. So that means that we don't have any voltage. Yeah, that's wrong. 0.5? Oh, okay, so I've really goofed it up. Let's check that, make sure I didn't do it upside down or something. That was supposed to be an equivalent chip. Either I grabbed the wrong chip for the wrong thing, or that's not an equivalent chip. It's alright, let's take it off. Figure out what I ordered later. I figured it out, or at least I got a lot closer. So let's look close up on the board here, and you'll see that I took off these two chips. So I took off 55, where there's a temperature sensor, and I took off 56. Now, when I took these two chips off, let's go back to our team miner page, and let me grab my meter, and let me hit the tester. What I'm looking for is 1.8 volts. Okay, so I'm going to go to the ground pad, and look at that, 1.8 volts. Let's go to the chip over. 1.8 volts. Okay, so those chips were bad, probably due to heat, and that was pulling the voltage down. At least that's my theory right now. So what I'm going to do, I'm going to put two chips on real quick, and we'll see what happens. Since those two chips were right there, you know, where I put nuts on, a lot of heat. It just destroys a chip sometimes. You put too much heat into that area. Okay, let's see if we've got the right voltage now, at least. Nope. So that was not the problem. We'll check the voltages up the domain. We'll see if we can figure out where the drop is really happening. And from there, maybe figure out which chip is actually causing the draw. Now let's go to the other side of the board. Oh, crap. Okay, I'll fix that in a second. Okay, the good news is I do have domain 11 is still good. Domain 12 is foobarred. Okay. Okay, it's good news. We've got voltage, it's good. It's just when it goes to through the fuse, it gets to the other side, it gets into that domain, something's wrong in that domain. So I'm gonna have to work my way up through that domain until we find out what's wrong. Same thing with this one, actually. This one is 1.2, so there's something wrong in that domain as well. Okay, so I got an idea. And that is, I took this chip off. I want to see, now that I interrupted the 1.8 volt path, I want to see if I get to 1.8 volts now. If I get to 1.8 volts at the LDO and on the other side of chip 55, then I know that chip 55 is not the issue. Could be chip 54. It could be one of these other chips. We're just going to work up the way here. One thing I did notice when I pull the chip off, it's really dirty under bad. A lot of corrosion and dirt. So taking these chips off, and even if I'm recycling them because they're okay, taking them off, cleaning up the pads is a good thing. So let's find out. Do I have my 1.8 volts? Okay, I got my voltmeter test. There we go. I got 1.8 volts. Let's go to the other side of the chip. 1.8 volts. Now, I can't go to the next 1.8 volt because there won't be any voltage there. Okay, so the path to that 1.8 volts is missing. Let me get that chip put in, and while I'm at it, I'll also fix the missing capacitor that's down here. I think it's cooled off. Let's give it a test, and let's see if we've got voltage. That would be good if we did. Oh, bummer. So we put this one back in place. Okay, so we know that it's not 55 and it's not 54. I don't know if you've run into this before and you found a quicker way to troubleshoot this. Comment down below. Let me know what you figured out. Okay, so, all right, we'll do 5.3. Okay, I'm glad I checked it because that tells me a whole lot. So checking it up there, I got 0.52, 0.52, 0.51. Huh. Okay, so it's one of these two, actually. Something going on with chip 54. Let me pull 54 again. Okay, board's cooled off. Chips 54 and 53 are removed. Let's find out if the voltage comes back on this domain. Yes, 1.8 volts. Good. 1.8. Good. And of course, nothing on this side because, yeah, that's what it's supposed to do. So, let's see what happens if we can put that chip back in. Okay, cooled off. Yeah, good, good, good. Let's see what happens. What the hell? I put a different chip on there and it made it worse. Okay, pull that chip. Board has had time to cool off. So now I've got 3 chips out of the way. Okay, I got 1.8 volts on that rail. Let's see, do I have 1.8 volts? I got 1.8. So when I take these 2 chips out, I got 1.8. Now, do I have 1.8? I got 1.8 there. Okay, so coming out of both of these chips, we have the respective 1.8 volt that we should. Okay, let's see. Can I do a jump? That's dangerous. here's the biggest problem I found. And so this is going to change my troubleshooting. If I put power to it and I hit the tester and I put my meter, I'm going to go to ground and I'm going to check these two diodes up here. That's supposed to be between 23 and 24.5. That doesn't look like 23 to 24, does it? Nope. So there's something wrong in that boost circuit. So I'm going to have to troubleshoot that boost circuit. Okay, I think we're making some progress. Put this on the negative and I check this to here. We've got 24 volts. That's exactly what we need. And now the values on the input for at least the top domains here seem to be correct. Now, down here towards the bottom domains, I still have some funny business, but at least now these three domains, the inputs feeding into the LDOs are correct. Now I've just got to get some LDOs on there that I trust. All right, so I have traced this domain down to a problem that I cannot figure out, which is if I check the power, if I check the resistance between the positive side of the 1.8 and ground, I get 34 ohms. So that's what's drawing the voltage down. So this is FB13. By breaking this, I break off the 1.8 volt. It doesn't keep flowing. So if I check across there to this side of this capacitor, which is in ground, it's 34 ohms. If I check on this side of the capacitor, it's like 0.1 ohm because there's a trace right here. So this shorts out to ground with 34 ohms. Anywhere I check to ground, I get that 34 ohms. I can check to the top of the chip or top of the heatsink, 34 ohms. That is the problem. So I don't know exactly what that is. I've taken off all these pieces right here. I took off this PLL for the 0.8 and it still has the problem. So there's something causing a short somewhere and I just have to find that. Once I find that, then this domain will be good to go. I don't think it's the chips. Hey there, it's day 3. That's right. 3 days working on the same board, and hopefully I'm shoving it all into one video. So what I've gotten to now is I've chased down domain 11 here. We probably have an issue with the 1.8 volt going into the temp sensor. Let me zoom that in for you. So by taking that ferret bead component out, what I can do there is I can get the voltage, right? I can measure it. So I know it's 1.8 volts. But if I go to this side, I don't have anything. So by doing that, I can interrupt this and I can troubleshoot this connection. And that's what we're going to troubleshoot next. We're going to try to figure out why it is that when I check my resistance to ground, so I'm going to come on the other side where I broke this circuit, and I'm going to test to ground, we've got 34 ohms. That's essentially a short. If I check in the domain over, notice the ohms are so high that it's not reading. There we go, 0.88 kilo ohms. If I jump over to the next one, 892. So you can see that's the problem, right? I can keep going, but it doesn't really matter. The big problem is that whenever I touch to this point, I get 34 ohms. So we're going to troubleshoot that because I've taken all the chips off the domain. That's not the problem. The problem is something in here in this chain. Let me pull up the diagram that I have and let's see if we can figure it out together. So this is the circuit diagram for the LDO and the PLL. So what I've done here is taken FB13, FB7 on this diagram, and I've pulled it off the circuit. So that way I'm not sending voltage past, right? That's what I've done to this diagram. Now, if we look at the temp sensor, let me move down to it. What I figured out is it looks like, based on my analysis of the board, and if I'm wrong, please, by all means, comment down below. But it looks like the 1.8 volt from the LDO feeds the temp sensor. Specifically, it feeds into pin 1. And I know this because if I put my tester from that pad of the FB13 and I go from there to pin 1 of the temp sensor, we get a very low resistance. Let me do that for you right now. So pin 1 of this temp sensor is right there. Okay, so what I'm going to do, I'm going to touch that, and I'm in resistance mode, and I'm going to go to there, 0.19 ohms, 0.17 ohms. Okay, so that means that from here to here, there's a direct path. You can see there's 2 capacitors and 2 resistors that we need to look at to see if they're bad. That's the only thing I can do at this point, is take those capacitors off and check them. So that's what I'm going to do. Okay, so what I think, if I'm looking at this, I think it's these 2 capacitors right here that are our issue. I can check that by putting my probe on pin 1. Then with the other probe, I can test these 2 right here, and I should see, yeah, 0. So I know that's the path, and the trace probably goes right there. So these 2 pieces right here go into there, and the other side goes to ground. So to rule these out, I'm just going to take them off. We still have the 34 ohms. So it wasn't these 2 capacitors that were bad. Could it be the temp sensor is bad? All right, let me put those capacitors back. While I was putting the capacitors back on, I decided to take the temp sensor off. That way I would have one less heat cycle. So let's find out now if the temp sense possibly was shorted. Let me see. I'm going to put the negative probe on ground. Oh, baby. We found it. We found it. Go here to pin 1. Okay. Temp sense apparently is shot. All right. Good news. I got plenty of these. If you need some, you can order them on Thanos. The link will be in the description below. It's also on my brianrecommends.tech page. If you need something that you see me using here, odds are it's on my brianrecommends.tech page. So check that out today. All right, let's just check our resistance now, see if we are still good. Bad temperature sensor is what it looks like to me. We're now running 30K. So I'll go ahead and put the ferrite bead. I'm going to call it a ferrite bead resistor. I'm not really sure what you call these. Correct me in the comments down below. Let me know what this is. It looks like, based on the diagram and so forth, it looks like it's a resistor because it's rated at 600 ohms. So, and milliamps. So, but the weird part is the way the drawing looks, it looks like it's a kind of an inductor. So whatever it is, I know it is designed to kind of control signal. Good news, I'm going to get this ferrite bead item here back onto its pad, and we're going to check and see if this domain has now been fixed. All right, let's see if we've got voltage now at this right here. We should have it. There we go. 1.8 volts. That's what we want, right? Now, do we have 0.8? Oh, yeah, we've got 0.8. Good. So now I'm just going to come over here. I'm just going to check because this is the other domain that just gave me absolute fits yesterday. 1.78 is good. And 0.8. Good. Okay, so let me put these chips back in place here and here, and I'll get these domains reestablished. Then we'll start working back through the board. There is another domain over here that's got some voltage problems on the right-hand side of my board. So we'll solve that next. But I think that temperature sensor problem, that feels like it was forever ago. I think that was because we had a failing temp sensor. Let me get some chips soldered on, and I'll be right back. The board's nice and cooled off. Let's get my probes. And let's find out if this board is going to come back to life. I want to check the voltage of this one. Okay, it's a little bit low. I feel like that's where we were before. Okay, maybe I got myself a little overzealous by jumping all the way through all the chips. So this was the problem we had before. Let's go back to our resistance. Let's check our resistance. Okay, good. We got good resistance there. Let's compare that to over here. Normal resistance. So that's not the problem anymore. Let's do some jumping and let's just see where we are, we still do have a voltage problem there, but I'm going to work around that for right now. Okay, we don't have anything there. We got weirdness there, right? Okay, let's go back to 10. Let's go back to 5. Nothing. Okay, let's go to 1. Jumping really didn't help. So let's check our voltages again. Ooh, wow, look at that. That's really low. That's a problem. Okay, so we have a domain problem. Domain number 1 is a problem. Yeah. Okay, what about domain number 2? 2 looks good. This seems to be the LDOs from hell. I'm going to come in. I'm going to take that FB2 out of the way. Just going to slide it over. Okay, so now domain 1 has been kind of unplugged. Let's find out what we got. Go to here, and I can go to here. Uh-oh. So we got another bad LDO. Okay, 5 in. 0.6 out. Hey, there you go. A lot of bad LDOs on this board. Okay. So I pulled a LDO off of another board. Let's see what it does now. There we go. That's what it's supposed to do. Let me just check the domain next to it. Make sure it's still good. Okay, so I didn't break the domain. All right. Let's put the FB back in place. Let's just check it while I've got it under the scope here. And see. That's not good. So something has us loaded down. All right, so we're back on top of the board now. Let me turn the tester back on. All right, good. Now let's find out, do we have voltage now? What's our voltage on the top of the board look like? That was just weird. We had it a minute ago and then we don't have it. That's crazy. How about domain 2? No, domain 2, we gotta come over here and test. Okay, domain 2 looks fine. What the heck is going on with domain 1? It's oscillating. That wasn't magically fixed. What about the 0.8? That's crazy. We get higher voltage at this end than this end? Okay, 1.5. 1.51, 1.53. That's crazy. Hey, look at that. We're climbing. What I'm hoping not to do with this board, I do not want to turn this board into a restoration board. But every time I take a chip off, what I'm finding is just filth underneath the chip. So I might have to just do that. I might have to take every single chip off. The good news is I can recycle all the chips. So it's not like I'm wasting a bunch of chips, but I don't have to do that if I don't have to. All right, let's put the tester on and find out. All right, so that wasn't it, right? Because when I check that, still getting some real low readings. So that's not that chip. Let's go to 4. All right, so there you go. That's another just disgusting chip. Let's go ahead. I've got the measuring there. Let me go ahead and turn the tester on, and we'll measure and find out if our voltage is better. So what we're going to want to do, put our negative probe there, and we'll touch to this guy right there, because that should be, if I put it in voltage mode, that should be 1.8 volt. Well, that's good news, because that means that chip 5 was not bad chip. We'll clean up chip 4, and I'll put chip 5 back in the recycling bin. It'll get cleaned up and test it again later. Let's see what happens if I replace chip 4. All right, I've got a hunch, and that hunch is that this is probably the bad chip for this one, but we're just going to keep going down the aisle. Let's test it. That's even crummier than before. Okay, there it goes. All right, so we know it's probably not 4. All right, let's take 3 off. All right, before I clean this up, let's test it and find out if that is the chip that's the problem or not. There we go. Good. All right. So, all right. So we know that chip 4 is good. Good. Okay. Let's keep going. Chip 3 is back on. Let's get our test probes and turn on the tester. Let's see what we got here. So that wasn't it, right? Because we're still seeing the same dropped off voltage. All right. Well, since I've replaced 2 already, let's take chip 1 off, because I know chip 1 hasn't been cleaned up. So let's take chip 1 off, and let's see if that fixes the problem. All right, let me hit the go button. Well, there you go. Look at that. Chip number 1 was the bad chip. I went ahead, I replaced chip 1, and I went ahead and reflowed chip 3. Just to see if that fixed the 0.8 volt problem. All right, let's see what we get. All right, looks like I may have jumped the gun in my fixing. All right, let's go ahead and take 3 back off, because maybe I messed it up. Because we had 1.8 all the way up to here. So, I feel like I did something wrong. Okay, let's get the power back on. Get this thing tested. Here we go. Okay, on the ground. There we go. All right, let's just check our 0.8 volt. There you go. All right. So maybe that was a funky chip. It's possible that I don't know. Possible I could have messed it up. Let's see if a replacement chip, though, solves the problem. So I've taken off chip 2 and tested 1.8. Let's go ahead, I guess, replace chip 2. Maybe chip 2 got damaged when the nut got soldered on. And get a new replacement chip on there, and we'll see. All right, let's test it, shall we? Here we go. That's better than it was, but not as good as it could be. Okay. 1.79, 1. Okay, we're good there. 1.79, good there. 1.77, so there may be something hinky with. Wonder if there's not a problem with a chip heating up over here. Okay, fine. Let's go ahead and let's get okay, 3, 4. Can we get 5? Got 5. Let's get 10. 16? No, it should be 10. 9. Cool. All right, that's the sus chip. Again, right around the nut, so we know that's a problem. All right, I'm gonna take that chip off and replace it. All right, that should be good and cool. Let's see what we got now. Okay, we left off with 10. That's disappointing. Expect 5. Start at 1. Okay, let's check our voltages real quick. I got nothing? Yeah, see, the voltage is low again, so... And we got nothing on this side, so there is something sus about that chip. Oh, okay. Maybe it's just not making a good contact. Yeah, there's something wrong in this domain. Alright, let's start back at this end, and let's go this way with it. Alright, after a long, arduous journey of replacing chips, basically it was most of the chips that were near a nut, right? Both of these chips, all 3 of these chips had to be replaced. One other thing I noticed was running my voltage really low. I was getting a lot of false readings, and that caused problems. So I went ahead, turned up my voltage to 20.98, so just right under 21 volts. And suddenly I was able to get some stability in the domain voltages. So this is an L7 board. Next time I see an L7 board, I may just turn it into a scrap board. But some of the damage on this board was caused from too hot of soldering nuts, and others may just be weak chips. But that being said, let's get into it. Let's see where we are right now. 65 chips. That, after everything that I've gone through, that's a wonderful thing. There were a lot of times I just lost my patience with this board, but we're good now. I like that. Let's see where the temps are. 71 chips. Okay. Something's not right somewhere. For some reason, on this tester, it thinks this is a hotter chip, which this would normally be temp 3 in the miner, but on the tester, it's 4. All right, let's check our voltages. We can do that. Okay. Seven, 9. 7's kind of weak. Okay. Look what's happened there. We've gotten funny values on number 4. Let's go ahead and take that chip out, 55. I know that 4 is not normally 55. It's normal. This is normally 3, but the tester has it all mixed up. So we're going to go ahead and take this chip out, replace it, see if that changes anything. Tell you what I'm going to do since I'm working on the board. I'm going to take out both chips, 55 and 51. That way I get both sides of the temp sensor issues. They're both by solder nuts, so that's why I suspect both of them. $65 chips again. That's good, good, good. All right, let's see what the temperatures look like because I took them both out, right? So we're not messing around. Oh man, that's funky business when we get one chip that rises up. So now we're 66 chips, but we shouldn't have 66 chips. We should have 65. All right, but at least these seem to be doing better. All right. I've got some new heatsink paste, but we're not going to use this just yet. We're going to go ahead. I'm going to paste this up with the cheap stuff, throw it in a miner, and let's just see where we are. Wait a minute. Hold on. Let's take this one out right here. Okay, that would be 2 by the tester. I know that technically 2 is up here on the hot side, but on the tester, it's down here. I want to take that one out. Ooh, see how it just dropped? Oh, now it popped up. So we're going to take that chip out. Right there. Let's get that one out, and then we'll hopefully get this thing off into a miner for testing. All right, we got 65 chips after the replacement of chip 15. Now, what I really want to see, 65 chips when I go into the test mode here. Oh, crap. Man, something is not right in the signal. All right, I'm going to go ahead and put the cheap stuff on. At the high 510, we'll use this. I want to just see how close we are to success. Is it 64 out of 65? Is it 0 ASICs detected? Will it even run? The nice part about putting it out there with the cheap stuff today is the intake on the farm is under 65 degrees. So just for basic testing, I should be able to get it running just fine. I got the screws, I got the heat sinks, I'm ready to go. Let me set everything on and get this thing ready to go. All right, I got 65 chips. I got 67 chips if you check out the tester there. All right, I'm going to get this into a miner and find out what's going on with this board. So it's day 4. Yep. I put the board into the miner last night, got it running, took my family to dinner, came home and went to bed. Didn't worry about it. This morning I checked on it, and as I kind of expected, the board had a few problems. It was hashing though, and that's a good thing. If I pull this in, let me zoom in on this. So if I pull this in, chain 1, this was board 005 running, and as you can see there, chip 20 has the problem. This is running at 530 megahertz, and the voltage 18.8. So at 18.8 volts, we had chip 20 drop out. Then the entire domain pretty much goes out here, 56 through 60. And then you have some weakness in this last domain. Now, that kind of disappoints me because I replaced every single chip here. 55 is weak. So here's my suspicion. If I look at this right here, I think this was when we had a power outage or right after we had a power outage last night. It detected chain 1, 19 of 65 chips. And then I tried it again. It said 19 of 65 chips. And then finally, third time's a charm, trying to initialize the board, it found 65 of 65 chips. 19 of 65. That is huge because where's our weak chip? 20. So what I'm going to do, first things first, get it back in the miner with just replacing chip 20, and I'll report back and tell you how it goes. All right. Chip 20 is in, cooled off, 65 chips. That's a good sign. I will say that chip 20 was an original chip because it had the black crud on the pad, so it's good that I took it off and replaced it. Let's see. Get 65 chips. That's a good sign. Temperature sensors read properly. So maybe that was it. Maybe that was the problem yesterday, was chip 20 being kind of weak. I'll get that back in the miner, let it run a few hours, and give you an update on what's going on. Board's been running a few hours. In fact, the board has been running 3 hours and 44 minutes, and it's still running. So for now, I'm going to count board 005 as operational. And does it need some help? Heck, yes, it needs some help. But let's take a look down here. It's in the chain 2 slot. As you can see here, the ideal rate is supposed to be 24 gigahash. It's running at 22. So it's not perfect, but it's certainly good enough for now, running at an average of 550 megahertz per chip at 18.8 volts. If I cut this down to 18.7 or 18.6, the card will start to have a lot of problems. But as you can see, all the chips right here, you can see through there that all of the chips are online and operational. If I click over to the other screen, you'll see that some of the chips in chain 1 here are not operating as well as I'd like. They are hashing, but instead of hashing at 300 plus, 400 plus, they're hashing down around 90, 175, and so forth. So they're lower than they should be. They're red or yellow level chips. The other big issue, and I'm not for sure if this is a heatsink grease issue or not, but chip number 2 was reading as 75 degrees. So it's running hotter than it really should. For now, board 005 is off of the broken pile, off the bench, and in a miner, hashing and earning Bitcoin. This has been a really long video. It took me 4 days, basically, of bench time to get all of this. And I'm sure that lots and lots of what I did is going to get left on the cutting room floor, if you will. So if you enjoy this content, please give it a like. If you want to be notified of future videos, be sure to hit that subscribe and notification bell. And if you know someone that's getting into electronic repairs, getting into ASIC mining, getting into crypto mining, and they want to do repairs themselves, please share this channel with them. You can also click on one of these other videos. I welcome all the new subscribers. Thank you for subscribing. Thank you for all of you who've been watching these videos. And I look forward to seeing you real soon.